Welcome to Hadoop Exam Learning Resources. In this session, we are going to learn about Spark Shell and creating a new RDDs from existing file which is stored in Hadoop file system. So let's start, and throughout the session we'll be using this PDF, and this PDF you can download from the description sections of this video. So wherever you are watching on YouTube or Vimeo, or from any wherever, so you can just look for the description sections, and from there you can get the download link for this PDF. So exactly, we'll be using this quick VM, that is in previous module we have uh, show how to install the quick VM provided by the cloud era. So by default the Spark installed in this, so we don't have to go through the entire installation process of the Spark. uh, we are here mainly to learn the Spark, how it works and everything. So the installation is just uh, extracting the tar file from download and some settings for the Hadoop file system. So let's start with the first this basics of Spark Shell and creating the RDD. So what exactly here we are going to tell you, like uh, so okay, let me use this to write something, this tool. Okay, so here exactly this is Spark Shell. This Spark Shell is exactly the driver program for your code. Okay, so mainly this is the main program similar to your Java code, correct? In Java we do have main class. So similarly the Spark Shell is the one of the way to run your program on the Spark cluster. So, and this is the cluster, you can assume this is Spark cluster with the multiple nodes in this. Similarly, like I can say this is Hadoop file system, the HDFS, or nodes where files are stored, and you are also leveraging the same node for your Spark Shell. So Spark Shell has the connections with this using Spark context object. We'll see like exactly what that I mean. So it can execute your program on this cluster on each node. So this way this distribute your RDDs and partition your RDDs across the cluster, and okay, let's go through the first hands-on so that you would understand more in detail. So Spark supports the Java, Python, Scala, every three languages mainly, and Spark is written mainly in Scala. Mm, okay, it's mainly Spark is written Scala, and Scala is is running on JVM. Okay, so Java runtime environment, it requires, like, it is Scala is written over the Java, exactly it uses the JVM. So and Spark is written over the Scala. So having a knowledge of Scala is good thing actually, but here in throughout the sessions, all the session will learn the basics of Scala and how to use it, and what Scala syntax and all this thing. So basic any programming language knowledge you have, that would be good enough to go through. You don't have to be expert on the Scala, Python or Java. That's fine if you have even basic knowledge. Throughout all our sessions we'll go through this step by step, and we'll learn the Scala as well, basically. Okay, so let me tell you, this is the quick VM. This is the Cloudera provided. We have installed it. We will do most of our sessions on this quick VM, because Spark Shell is installed, HDFS is already there, so we will read files from the Hadoop file system. So we don't have to configure the HDFS and then Spark separately. So everything is already there, and this is freely available. You can download and install it. Okay, so just to open the terminal here by clicking here and just typing the Spark Shell here, Spark Shell. Okay, it will start the Spark. So just wait for a few minutes to start it. So here you can see, like, this is the logger information is coming, info. So while Spark started, uh, all the logs are being printed over here on the info level. We are going to change this log level once it is started. So you can see here the Spark version is 1.3, current production version is 1.5.0. So we'll be using this Spark right now, 1.3.0 to learn Spark. Okay, so this started. So you can see here like the Spark shell even by default started using the Scala. So this is in this shell you can write your Scala code as well. Okay, so because Spark is mostly using the Scala in the background. Okay, even now it support the Python, Java, etc. But okay, so now where is Spark installed on this quick VM? The Spark is installed under the user lib directory and Spark. Okay, so let's move to the go to the folder. Just open the my computer here, file system, go to the user and go to the lib and then Spark, search for the Spark. So Spark installed here. Now you can see here like all the in the I see here log level. So this is quite verbose. We don't want this entire log information all the time keep coming. So we want you to change this log level. So we don't want such a huge information while running the program. So just go to this location, just copy this location here I have given in the PDF, user lib and Spark. Copy and go to the terminal, open the new terminal. Okay, and go to see this location, user lib and Spark, and inside this go to the configuration directory. So here you can see like there is a log4j properties template provided. So you have to copy this template into the log4j properties and then change the log level accordingly. Okay, the important point here is like you can see here the users are the root level user. So we don't have permission to copy in this direction in this directory. So we have to change the user for this because current user is you can see Cloudera. So this user don't have permission to do anything on this, correct? So let's go to the using the sudo command, sudo su root. You just change the user. So now you have root user. So your whoami command is the root user. Okay, now copy this file, log4j properties, copy, paste here and paste, and remove this template part and copy here. So here in the const directory we have new file log4j.private. Let's change its mode so anybody can edit this file because only root user can edit by default. Copy this and paste. So now here everybody has permission to change this file. Now let's go to this Spark directory. Inside this conf file, open this log4j file we have created, open with okay via editor, and then this log level change it to info to some warning. Okay, let me close this file again because we are unable to we open cancel. Let me open other application. Do we have any editor to change it? Gedit. Let's select gedit. That is a good editor. Okay, and just type wow. So this is normal text. Okay, we are still not could not create a backup file while saving user. Save anyway, it won't want backup file to be created. Okay, so let's open it again whether it has been changed or not. Open with via. Okay, now we can see here the warn is the log level. Now in our terminal, let's close this terminal, exit from here. Okay, just exit and see whether we can again see this log level. Now start the Spark shell again. It will take a little time because now we cannot see this log level, so we will see like the response is coming a little late. So here you can see on warning level of the logs are being printed over here. So like it would be less verbose, correct? Now and when you run your program, the whole info would be printed. That would be not a good idea. So to avoid such a thing, we have to change the log level. Okay, so now this is being started, so not started. Let's move to the next. We have changed the log level. Now create a file in the HDFS file system. Okay, now as mentioned over here, the instruction change the value from info we have done using the hue. Use the tool for the HDFS file system and Hadoop framework we do have, so we can change the log level, sorry, we can create the file here. So let me show you how it works. So let's just open a Firefox here. Okay, in the Firefox, in the quick VM, you can just click on the hue, so it will open a Hue web UI, that is HUE. Okay, so now in the file browser, this file browser is for the HDFS. Whatever files stored in your HDFS file system would be shown here. So let me just close this down. Okay, so now clicking the file browser, you can see all the files and folders are available in this directory of the root user cloudera directory of the HDFS file system. So now I want you to create a new file. Okay, so just go here where we can do this edit profile, job browser, action, click here. Can we create a file here? Okay, there is the file creation button. Okay, this is the new. Here you can see we can create the new file. So as shown in the PDF, we are going to create spark.txt file, copy it and paste this. So create. So now you can see spark.txt file created with 0 bytes. Now edit this file. Okay, just by clicking on this I can inside the file, but there is no content. The current file is empty. So just edit the file, copy the content from here. It's just a dummy content here. We are going to copy and paste and save this. So you are creating this file in the HDFS file system. Okay, so now let's go to this Hadoop and open the terminal and copy this command HDFS DFS and list all the files. Okay, so let's open a new terminal and just paste this command HDFS DFS, so it will list all the file on the Hadoop file system. So whether we see whether our file is available or not here. So let's wait for this output to come. This VM is little slower here right now. So this spark.txt has been created with 68 byte. Okay, so in 31st October we have created this file. So now let's move to the Spark shell we have there. Using Spark shell we can do big data analysis and all these things. So let's write the below program, what exactly this program is done. So open the Spark shell. So this is the Spark shell. Now we have the file. So just value lines sc dot text file. So what exactly we are doing here, we are reading the files from the HDFS file system. By default, as this Spark is configured for pointing to the file system HDFS, So whatever the file name you type here would be looked for in the HDFS file system. So let's first type the wrong file name. Okay, let me change here. Okay, let me give you this file name here, spark1.txt, which we don't have right now. Okay, then enter this. Okay, what exactly it does. Okay, so it has created the RDD, which is pointing to this file. Okay, but now it has not yet pointed out because this is the lazy evaluation. We'll talk about this. So it is just creating an empty RDD which points to this spark1.txt. Now, but when we try to read this file, okay, so lines.count is the action we will apply on this RDD. So which is exactly go and read your file from the HDFS file system. Now see what is the output when it tries to read the file. It is clearly exception. What it says, this the input path does not exist because this is going to read from the HDFS quick start cloudera user cloudera spark1.txt, because we don't have file inside this HDFS, this file spark1.txt. So rather we'll remove this spark1.txt and then just spark.txt. We have the file. Now let's count the line from the this RDD using lines.count. Okay, so now here we are clearly getting the number of lines. So this RDD is exactly pointing to the files which is stored in this. So let me show you. This is our file which contains 2 lines. Okay, this is the file which contains 2 lines. So this is the, as in the Spark new RDD would be created. This RDD creates 2 lines, first and second, and when you apply the action on this, like getting the count, it will give you the count of this line. So 2 lines are there. Now let's move to this next. What exactly lines dot first? Now print the first line of this. Okay, so just paste it. Okay, lines. So you can see in our files we do have spark is the first line. So this is being printed, correct? So now let's choose the content of this. How to pick that? Save. Just save this file, and now again try to do the same thing on the terminal. Okay, this is the terminal. What exactly it does? Now you can see it is going to read. So that is the beauty about the Spark. Exactly, this RDD, whenever you apply the actions, the RDD will be recalculated. So rather than like we have seen, like in it doesn't keep it in memory until and unless we say explicitly. Otherwise it will again go to this file system and read the file whenever you apply the action. So this is first is the action count is an action, and this is the transformation as c.text file. We'll discuss about this in few next upcoming sessions. So this is what RDD represent this. This is immutable, so you cannot change it once it is created, correct? So lines has been created, and we want to, if modify or something, some actions like lines dot add or something, we want to do this, we cannot do this because it will recalculate all the time, and it is immutable once it is created. Okay, so now let's move towards this again. So Spark core concepts we are going to discuss here. So every Spark application consists of a driver program. So similar to in Java programming model, you write a Java program, correct? So so there is always a main class for the entire jar file. If you have jar files, lot of classes inside this, correct? So in this classes, one of the files should be the main file which start the program. Similarly, in the Spark there has to be a one file that is the driver program. In the Hadoop files, in the Hadoop framework, in the MapReduce also we have seen like there is a driver program. Okay, Similarly, in the Spark also there is a driver program. So in this example we have done over here is this Spark shell itself is our driver program here. So this contains the main functions and defines the distributed data set on the cluster, then applies the operation on that. So this entire operation would be applied like this lines dot first. If our file is so big, let's assume it here 2-3 line files, but generally in the big data system this file are so huge. This is huge that are distributed across the cluster and divided into the blocks. Correct. So what RDD is does actually, RDD represent this entire file which is distributed across the cluster. So let's say your file is in terabytes and you have 3 node cluster. Not necessarily it would be a Hadoop cluster, correct? It could be where it could be a Amazon S3 file system. So you can have your file into the cloud. So this is your entire file divided into the block and stored into the on these 3 nodes. Sorry, on these 3 nodes. Our file is so sorry, some disturbance is coming. Okay, so this is our file which is divided. So when you create the RDD out of this, and if you have configured cluster, so this is RDD representing actually 3 blocks. It depends on runtime calculated. I'm just giving you examples. So like three partitions would be created on this, and whenever you clients.count you fire or action is applied, so this count goes to this count goes to this, and this is also goes to this. Individually everybody would count like 100 lines, it has 2000 lines, this is 5000 lines something. So this all counts would be written to the driver program, and 100 plus 2000 plus 5000 would be summed up and then given to you 7100 as an output. So this is the responsibility of the driver program to collect back the and distribute the work across the cluster. So you don't have to worry, you just need the cluster configuration, that's fine for you, and the distribution of your data and RDD partitions and getting back the results and all these things is done by. So we can customize this all thing. We'll see in the future sessions how this can impact and how we can customize all this thing. Okay, so the driver, so here the Spark shell is our driver program. This and to access the always Spark context object. So like in a Spark there is a cluster, correct? Again the multiple nodes cluster. So this whole cluster configuration, how the Spark gets it actually, so Spark shell gets it. So Spark shell is a one special object of class called Spark context. This is very important class that is called Spark context. So this Spark context class contains the configuration of your cluster configuration, where is the driver node, where is the master node, which are the all slave nodes, their IP addresses, their memory configuration, everything stored into the Spark context. So once Spark context is loaded into this your Spark shell, so it knows where is my all the node and which node is alive and which node is not alive. So this kind of communications and everything is can be done using the Spark context. So what is the name of the Spark context object in the Spark shell by default provided? That is very short form of Spark context, that is SC. So here in your program you can see here like so this is this sc.text file we have used. We have not created this SC object, correct? By default it is being available on the Spark shell. This you can see here. So we have never created this object. So whenever you open the Spark shell, so just type SC here, it will give you the what is the object and which class is the actually. So org.apache.spark context is the type of this SC object, correct? So using the Spark context object, we have loaded this text file from the HDFS file system into the lines. So here lines is an RDD which represent this entire file throughout, which is like that file size could be anything. Okay, and you applied the action on this RDD. This is count. This is the action. You can also apply transformations to create another RDD. We'll see in future session about this. So count. So it will just give you the number of lines available into the RDD. So now change the number of lines again. In the go to the hue and type the quicktechie.com and then google.com. Okay, and save this file. Now apply lines.count again. How many lines is there? 2 lines, because okay, so here's a surprise. So load it again. So now here is the 4 lines. Okay, so it was by default stored into the memory, this lines object. So let me check here. It should not happen like that. Whenever we change here the first line, it again go and calculate it. But in case of the when we change the when apply the lines.count, it already is given the output which is stored here. So we have not persisted it by default. I don't know. Okay, we have loaded it back and then gets the lines.count. So it's 4. So there is some little difference. We'll see how exactly it was. Okay, so now so this is little surprise here. Okay, so, so just type sc and we'll see the spark. What type of object is this spark context here? We can then run the various operation on this, such as count. This is the one actions, then this is the getting the first line, this is again an actions. So to run this operation, driver program typically manage a number of nodes. This is called the executor. So here in the diagram we can see like this is all the executors, okay, on the worker node. So this is the driver program where which our shell is running, and this could be another computer on the same computer, and these all are interacting with each other. So this is our shell program which is point using this worker node 1 and 2 here, and running our executor exactly the action which we are going to apply. So let's use the lambda approach. So you know that recently now in the Java 8 this is also implemented. In Python it is called lambda, and this is exactly the functional programming. So what exactly is functional programming we'll see in detail in future session, but here I'm going to just tell you, which is very simple to understand, and this is not at all complicated. So what exactly here we have created our lines RDD, correct? On lines RDD we want to apply, we want to filter based on some logic. Okay, so like we want to filter the lines which contains the Hadoop exam and give me all the lines. Okay, so here what exactly, this is your lambda function. Okay, so passing another function to the function. So this is contains either my function exactly. So this is another function. So here you just assume it, this is the lines is the collection, which is the each lines is an RDD which is the collections of lines from the file. So we have 4 lines here. So on each line we choose, select whether this line filter out whether this line contains the Hadoop exam or not. If this line contains, then return the line, this line. If line doesn't contain, then don't return this line. So by default this filter function would be applied on each line of the collection. So these functions, let me copy this. If I can copy, okay, here I cannot paste exactly. Okay, so let me write down here. So line and this, and then line dot contains is my function, and here the Hadoop exam.com, Hadoop exam, correct? So exactly, you in normal this is anonymous function. Okay, so there's no name to this function, so you can just assume it, this is the function body which contains this line, dot contains Hadoop exam this and return. What would be written here? This line would be written here. Okay, because this is the return type, so I can say this return line. If this statement is true, then return the line. So you can just, this is the body part and this is return type, and this function is passed whatever the return of by this function is true, and then if this true, then it is true. So very simply you understand, this lines is the collections of the line which is an RDD apply on each line. This is line is the parameter for this variable represent the each line of this variable contains the Hadoop exam, then return the line. So this is very basic understanding you have, because throughout all the sessions will be using this functional programming, and which is very important. If you don't understand right now, then you can also try to read somewhere from a Scala book or some tutorial. So we'll in future also keep adding material on this, so you can learn this. So just right now understand, on each line of this apply this function and return the Hadoop line. So let's go to this, copy this and put into our terminal here. Correct, Hadoop lines. Okay, so enter here. So now this is the partition, this is another RDD would be created, because this is filter function is a transformation, not an action. Correct. So this filter will give you another RDD. The name of the RDD is Hadoop line. So this Hadoop line contains all the lines from the lines which contains the Hadoop exam. So based on our view, let me close down this here, we have this line, second line, which and first line, two lines, correct, contains the Hadoop exam keyword. So now let's go to the PDF again and get the first line which contains Hadoop exam. Okay, so just paste it and let's see the output. Okay, so this is the first line which contains the Hadoop exam. Now let's do the count. Logically it should be the output should be the 2, correct, because we know in the 2 lines this contains. Okay, so this is the Hadoop exam lines. So there are 2 lines which contains the Hadoop exam. Okay, so this is the function based filter operation, which if our file is so big, like assume this lines is too high, like in the big data file system, like huge file terabytes of size, then it would be this filter functions also applied throughout the cluster on the all the nodes of the cluster. So each file individually on each node would be processed. So Spark automatically takes your functions. This function will be taken by Spark. So like lines dot contains Hadoop exam and shift it to the executed nodes. So like this is the executed nodes on this, and this is the data RDD would also be partitioned over here, and you write code in a single driver program. We have write our code over only single file here, and automatically have parts of it run on multiple nodes, so you don't have to take care of this. Spark itself will take care of this. So that's all about the Spark in this session. So we have created RDD, so we want to keep the session as small as possible, and want to give you as much as hands-on session. So we will end the session over here, and you can use this PDF like while learning, and you just install the quick VM and do your own hands-on, so you'll get better feel of your work whatever you have learned. So we have Spark related solutions like Spark certification material and Spark training. So keep visiting hadoopexam.com. We are keep launching new materials, so which would help you to learn new disruptive technologies. So thanks for watching, and I hope you like this session. You can just provide the feedback if you want to give any feedback. We have introduced PDF material, so which after the watching the lesson you can read this PDF, you can just take the printout of this PDF, and that's you can use it. So we'll try to give you as much material as possible. Thanks for watching.